You know what? No, this. All right. Welcome back. Hope everyone had a good break. But we're going to be right back into it. We have a test on Thursday. So I actually made a review for you this time. And what I thought we would do is work through this review today. Sound good?
Yes, sir.
And I thought what we would do is start in the back at number 9 and work our way backwards. Just because I think the problems 1, 2, 3, and 5. 1, 2, 3, and 5 are kind of straightforward. The word problems are the ones I think you need the most work with. Would you agree with that?
Yes, sir.
Okay, so let's go ahead and work through starting with number 9. You probably don't remember this, but we were talking about inventory control. That was the last thing we did. I think I'm going to offer that as a bonus question on the test. I'm not going to actually test it on the test. Does that make sense? All right, so that's why you don't see the inventory control. That was the one where they had the, what was it, CDs or DVDs? You have to pay to store them, and okay, so we're not going to have that on here. All right, let's start. Number 9. Everyone has a copy of this? Okay, number 9. Let's start out. Read the problem. A fence is to be built as shown below, with metal fence costing $9 per foot, wood costing $6 per foot. If the budget for the project is $2,000, what is the largest possible area? So in this drawing, there's a few things that I need to make sure you understand. You have this building here, right? And then you have your fencing material, which I guess I'll put the fencing material dotted so you can kind of see. This is your fence. You do not need to put fence up against the building. Does that make sense? So you only need fence here, 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 and here. This side has to be metal, metal, wood, and wood. And you're also given that the building, the length of the building is 30 feet. All right? So you have a budget of $2,000. What is the largest possible area fence that we can make? Everyone understand the question? So I'm going to start out by coming up with a cost function. I want to determine how much it's going to cost me to build this fence. So the cost should be equal to, well, I've got to build this much metal fence, right? This much metal fence, this much wood, and this much wood, right? So let's just label these. I don't want to label them M and W. I'm going to use something else. That's just to remind you that that side's wood, wood, metal, metal. So why don't we call the distance from here to here, why don't we call that X? Is that all right with you? Okay, let's call that X. Would you agree that this is also X? Yes? Okay. Now, the distance from here to here, why don't we call that Y? Is that okay with you? Now, what is this? Y minus 30. Okay, that's one of the keys to the problem, is to understand that if this whole thing is Y, then this little piece is the entire Y, but take out that 30. So Y, take away 30. Y'all with me? Okay, so now let's talk about the cost. This is going to be metal fence. This is going to be metal fence. How much does it cost me to build metal fence? That's my budget. That's how much money I have for the project. It's $9 per foot, right? So if this is X feet and this is X feet, then together that's 2X, right? And I need to multiply that by 9 to get my cost. So let me write that down. I'm going to do 9 times 2X. This is the price per foot for the metal fence times how much metal fence I have. I have 2 X's. So this is the metal right here. Metal cost, or I'll say the cost of the metal part. And then we're doing plus, now we need the cost of the wooden part. So how much does a wood fence cost me per foot? $6. 6, and then what am I multiplying that by? Well, how much fence do I have that's wood? Y plus this, right? So what is y plus y minus 30? 2y minus 30. Does that make sense? Any questions there? Sure? Okay. So let's clean this up. The cost is going to be 18x plus what? 12y minus 180. Agreed? That's how much it's going to cost me to build this fence. 18 times whatever the x measurement is, plus 12 times the y measurement, subtract 180, that's my total cost. With me? Now, how much money do I have to spend? $2,000. So I want this cost, and I'm going to use my entire budget. It's kind of assumed in the problem. I want to build the biggest fence possible. I want to use all $2,000. So do you agree that this has to be equal to $2,000? Yes? So I'm going to replace the left side with 2,000 equals 18x plus 12y minus 1,800. Or sorry, 180. And I guess you could do one more thing here if you wanted to. How about adding 180 to both sides? Just add 180 here, add 180 here to get rid of that number? Yes? Okay, so I'm just going to box this for now. We have not done anything that has required any calculus at this point, right? All we have done is determined an equation that gives me how my cost is related to my picture, right? You give me the x, I need to figure out what x and y will make this thing true, all right? So I need to figure out what x and what y is going to make this thing, this equal statement, a true statement. But read the question. What is it asking you to actually find? The largest possible area, right? The largest area. So when we've been doing these problems, we've been trying to find maximums and minimums, right? That's what this whole kind of last couple of sections has been about. I'm going to try and find the quantity that I want to optimize. And what I want to optimize is the area. I want the maximum area. Everyone agree with that from the wording? So let me go ahead and write that down now. I want the maximum area. All right, I want the maximum area. Can you tell me from the picture what the area of our fencing enclosed area there is? What is the area? X times y. Everyone agree? The area is x times y. So I want to know when this can be the maximum possible value, right? The problem that we have, though, is that our area depends on two different variables. It depends on x and on y. And all the problems that we've done where we find the max and min, we've had a function of a single variable x. We did not have x and y in there, right? Yes? Like, I mean, if you flip this over and look at number 1, say find, where's the function going up and down, right? Find the local maximums and minimums. That's a function of x. There's only x's in there, right? Our area is not a function of x. It's a function of actually two different things. But how am I going to get around that? How can I get around the fact that this has two different letters in it? What can I use to actually continue to work through this? This is a long spring break, I know.
Can we solve for one of the variables?
Yeah, what we can do is go back up to this cost equation, right? And we can take this equation and solve it for x or y. If I solve this for x or y, I can now take that answer and plug it in here. All right? So that's why this was so valuable to us. This allows us to now move on to the next step, which is to replace x or y with something from here. Now I'm going to solve this for y. Even though you could do it for x, I'm going to solve it for y. So everyone, I'm going to erase the picture. We're going to take that cost equation right here and let's solve it for y. So if I solve that for y, I'm going to get 2180 minus 18x equals 12y. Right? All I did was subtracted 18x on both sides. And then I'm going to divide both sides by 12. Okay? So I'm going to do 2180 divided by 12. Ugh, it's ugly. It's 181.66. We'll just round 2 decimals, all right? 181.66. Everyone understand I'm just dividing each of these by 12? Yes? Okay. So 18 divided by 12, 1.5x equals y. With me? Okay, now I'm going to take that information. This is what y has to be equal to. In order for us to build this fence and spend all $2,000, y has to be equal to this. I'm going to take that value and I'm going to replace this y with that expression up there. So let's now rewrite. Now I'm going to rewrite the a equals xy to be a is equal to x times 181.66 minus 1.5x, close parentheses, there. So that's y right there, isn't it? Any questions? Your test is in 48 hours, so are you? Now's the time. Distribute the x through, and we will have our function. Okay, so here's what we've got. Area, and I'm going to put a of x here. I'll talk about why I do that in just a second. 181.66x minus 1.5x squared. And that is my area function. So I put a of x here because I'm stressing to you now that my area depends on only one thing, x. You give me x, I give you the area. Not only will I give you the area, I'll give you the area that spends all 2,000 of your dollars. Okay? So we want to know exactly where this is the biggest it can be. So how do we do that part? Take the derivative, right? Number line, test points. We're looking for it to go up and then down. Okay? So let's do this. I'm going to take the derivative of this function. And what would the derivative of this function be? Okay, so derivative of that right there is 181.6. That's all right. You can do it the other way. Then derivative of this, the 2 comes down, multiplies times that. You should get negative 3x. What do I do with that? Set it equal to 0. So if I take the derivative and I set it equal to 0, that means I'm going to take 181.66 minus 3x, set it equal to 0. And this is just a little linear equation. You can move things around and divide through, and let's see what we get. It was about 60.5, 60.5, 60.6, something like that. Okay? Now, this is going to turn out to be where we get the maximum area. But you still in your test need to show me that this is a maximum. So how do you show me that this is a maximum? Test points, right? You have to go to your number line now. You're going to put 60.56. You're going to plug some test points in here. I don't know. How about we plug in 1? 1 seems like a pretty easy number to plug in. And over here, any number we want, let me go with 100. And where am I plugging these in? To the derivative. And here's my derivative right here. So if I plug 1 into this, I get 181.66 minus 3, which is a positive number. So that means my original area function is going up here. That's good, right? Area's up, and now we just hope that it goes down. So if we plug in 100 into here, we get 181.66 minus 300. That's going to be a negative number. So that means my area is going down here. And from that information, I can conclude that I have a maximum area when x is 60.56, right? So that's my conclusion. And then I'm going to make sure that I answer the question, because I don't think I've answered the question yet. So we have a maximum area when x is equal to 60.56 feet. Now, what is the question asking? What is the largest area? This is not the largest area, is it? This is the x that gives you the largest area. So how do I actually figure out what the largest area is? Plug that into this, not the derivative, right? The area function. And that will spit out the maximum area. So let's go ahead and take this. Let's plug in 60.56. That means I'm going to do 181.66 times 60.56 minus 1.5 times 60.56 squared. So you've got to do that, on your calculator. Anybody else getting about 5,500? About 5,500? Yeah. This comes out to approximately 5,500 0.06. It doesn't, I'm not going to be too concerned about the last little decimals there. But this is your area, right? This is the actual maximum area. So this is feet squared. That's the units we use when we're using area, square feet. That's it. Okay? I just erased what I was going to need, but we've answered the question. That's it. We're done. Okay? Good? How do you feel about that? It's a lot of work, right? But that's probably one of the most applicable problems that are on this thing. Like that's sort of a real world type thing. Can I move on to 8, or should we talk about, this more? Anything else you want to discuss? Remember, the one I gave you in class was different than this, right? The one I gave you in class was like, I think it looked like this, I believe. And I had the same idea. I think I had like chain link fence, and then I had wooden fence, and so the setup was different. And I actually didn't give you money. I didn't give you a budget. I actually told you what the area needed to be, and then you had to actually figure out what the minimum cost was. So you want to go back and look at that, because I could give you either version or some other variation of it. I'll probably stick to something like this or the one I did in class before, though. All right? All right, now the next one. Number 8. A car rental company rents 300 cars per day at a rate of $40 per day. For each $2 increase in price, 6 fewer cars are rented per day. What should the daily rate be adjusted to in order to maximize income? And then what is the maximum income? So y'all remember how I did this? I started out, I think, for number 8, I started out with a table. I think that's what I did. And then what I said was, if this is the price, then this was the, I'll say, number of cars rented. And what we try to do is establish some sort of pattern. So we start out with $40. We should expect 300 cars to be rented. Yes? And then what did I do?
You increased it, the price.
I increased the price by, let's see, in this case, $2. So at $42, I should expect $294. Six fewer cars, right? And at $44, I should expect $288. And I was only doing this to try and come up with a pattern, right? Just so we could kind of see what's going on. Price keeps going up by $2. The demand of the cars keeps going down by 6, right? So 282 would be next. So this goes up by 2. These go down by 6. So then what did I do? I know this was a long time ago. I create an equation from that. Somehow I'm going to try and connect these two together. This right here, the number of cars rented, we could call that like the demand if we want. Equation, what will our equation look like? Okay, good. Remember, X is going to be equal to the number of price increases. Okay, that was the key, is that we need to understand that X was not the number of cars or the price or anything like that. That X is how many price increases we should do, right? All right, so what now?
Why is price times cars rented?
Okay, so we're going to try and come up with an equation for our income, right? Our income. Our income, I'm going to call it I, is equal to, what would our income be? The number of cars that are rented times the price we charge per car, right? So it's this times this, this times this, this times this, right? So how do I do that? We're missing something here. X is the number of price increases. Can you give me an equation that somehow gives you the price of the car that involves the X in it? P would be what? 40 plus yes? Hello? Y'all there? Y'all have your notes? No? Y'all see what we did last time? Let's see if y'all agree with that or not. If we do 0 price increases, how much are we charging per car? 40, right? Okay. If we do 1 price increase, so X is 1, we're going to be charging $42. We do 2 price increases. So this was 1 increase, This would be our second increase. This would be our third increase. So does this equation tell you what the price is of the car? Yes? Okay. Can you tell me what the demand of the car is? I'm going to use D for demand. How is demand related to the number of increases? So it starts out at what? 300 minus 6x. There we go. Minus 6x. So if I have 0 price increases, the demand is 300. If I do 1 price increase, the demand comes down by 6. 2 price increases, it'll come down a total of 12, right? So on and so forth. So this is the price, and this is the demand. The income should be the price times the demand. This is how much you're going to charge per car. This is how many cars should be rented. So if I multiply those two, that's your income. Yes? Okay, so price times demand. So price should be 40 plus 2x, and then demand is 300 minus 6x. And then we just multiply this all out. So let's multiply here to here, here to here, here to here, here to here. And we're going to get a quadratic equation, and it's just going to have x in it. So that's why I'm putting I, income, as a function of x. So what is that? 12,000 minus 240x plus 600x minus 12x squared. And that should be 12,000, was that plus 360x minus 12x squared. Are we done? Are we done? No. Pardon? Yeah, you clean this up, yeah? This gives us, this function right here gives us our income, and it's based upon how many price increases we have. And we would like to know when that income will be the highest, right? So again, this problem is broken down at the very end of the day. It's broken down to, we have a function, we have to figure out when its highest, what its highest point is, right? So we do derivative now and all that stuff, right? Okay. So let's take a derivative and get rid of this. Okay, derivative of this is, derivative of 12,000 is 0, right? Derivative of 360x is just 360. And the derivative of this is negative 24x. So 2 comes down, hits the negative 12. Now I set that to 0 again. So that'll give me 360 minus 24x equals 0. And who has that for me? What is that? What is it? What is it? 15 even?
Yes.
Oh, it's 15 right in there. Okay. Good. X is 15. Now we have to verify that that's going to give us a maximum. So here's 15. Split the number line up. Pick some values. How about 1 and 20? And where are you going to plug those in? Derivative, right? So if you plug in 1, what happens? This is our derivative. Plug in 1, we get a positive, don't we? So that means our income function is increasing there. If we plug in 20, we're going to get a negative. That means our income function is decreasing there. So that means we have a maximum income when x is 15. Interesting. X is 15. Now have we answered the question? No. The question says, there's two questions. What should the daily rate be adjusted to in order to maximize income? So, well, isn't this the price? Oh, wait, sorry. Yeah, this is the price, right? That's the price? So our price should be maximized when x is 15. So we come up here to our price, and we say our price should be 40 plus 2 times 15, which means, what's that, 30 plus 4, that's 70. That means we need to be charging $70 a day for our vehicles in order to get the maximum income. Now, just for the sake of doing it, what's our demand at 70? We get 300 minus 6 times 15 again, right? Now, I noticed when we did this and I walked around, some students had problems with this. With your demand here, your x is 15 again. You don't take this answer 70 and plug it in here. It's 15. So 6 times 15, what's that? 90. So if you take 300 and subtract 90, what do you get? 210? So we're gonna be charging $70 a car for the day. We should expect that we're only going to have 210 people rent vehicles now because our prices are higher. But this is going to maximize our income. So the answer to the first question is this, right? What should the price be? What's the answer to the second question? It's the price times the demand. It's okay, if you get $70 for each car and you get 210 rentals, what does that multiply together? So the income, what is it? 15,000? Say it again. 14,700 even? This is our max income. So the two boxes here are the two answers. All right. How do you feel about that? All right. All right, let's do number 6 before we do number 7. 6 is a little easier to do. A company manufactures and sells X ceiling fans per week. The weekly price, demand, and cost equations are given. Part A, how many ceiling fans should be produced and sold to maximize revenue? What is the maximum revenue? How many ceiling fans should be produced and sold to maximize profit? What is the maximum profit? So we had talked about this again. I realize this was before spring break, so you probably don't have much of that left in there, no? A lot of time over spring break, you just completely reformat your hard drive, right? All right, well. Any help on this one? Part A, we're trying to figure out, we want the maximum revenue, right? That's what we want, maximum revenue. How do we determine revenue? There's a formula for it. Price times. So remember this formula. Revenue is equal to X times P. And that really means X is the number of units sold, and P is the price per unit. You have to remember that, you have to know that formula. Revenue is X times price. Right, if I'm going to sell these for $30 a piece, then how much money I bring in is 30 times how many I sell, right? So this is how many I sold, and that's the price I sold them for.
Are you going to be able to bring up those notes this time for this test?
I did that last time, right? A little cheat sheet. Yes, but it must be completed before you get here. All right? So like when the test starts, if you don't have a cheat sheet, you don't have a cheat sheet. All right? All right. So I want the maximum revenue. Can we figure out our revenue function then? Well, I give us the price equation, don't I? For number 6. So isn't our revenue going to be x times 120 minus 0.5x? That's our revenue function, isn't it? Revenue times price. I'm not using cost. I gave you cost, right? I'm not going to use cost yet, right? I'm going to use cost when we do profit. So the first part A and B of this problem require just the P function, or the P equation. Now distribute the x through. I'm also going to write R of x because the revenue is a function of one thing now. 120x minus 0.5x squared. And now we're just going to play the same game, right? Take the derivative, set it to 0, number line, test points. This is repetitive, right, at this point, this part of it? So what is my derivative? 120 minus x. Set that to 0. And you get a pretty nice answer, right? 120, x is 120. Number line, test points. I'll plug in 1, I'll plug in 200. Where am I plugging these in? To the derivative, and there's my derivative. So if I plug in 1, I'm going to get a positive number. If I plug in 200, I'm going to get a negative number. That means my revenue function is going up, and then my revenue function is going down. Feel good? Okay, so we get a maximum revenue when x is 120. Can we answer part A? How many ceiling fans should be produced and sold to maximize revenue? X was the number of units we're going to sell, right? So this answer is part A. Part A, I'll put the answer up here. We need to sell 120 units. Part B, what is the maximum revenue? So what are you going to do for that? Plug 120 into the original function right here. This gives you the revenue, right? Don't make the mistake of plugging it into the derivative. So for part B, the maximum revenue, we're going to do R and we're going to plug 120 in. That means we're going to do 120 times 120x minus 0.5 times 120 squared. Anybody got that yet for me? Oh wait, I don't know why I put 120x. Take that x out of there. I replaced the x with 120. $7,200. Any others out there agree? Yep, okay. $7,200. All right, A and B are done. Now what we need to do for part C is not look at the revenue function, look at the profit function. So you need to know the difference between the two. Now here's our revenue function, right? We're going to actually use this. We're going to use it. So I'm going to keep it here. For part C, we're looking at the profit function, right? And what is the definition of profit? Profit is equal to revenue minus cost. Money coming in minus the cost of running your business. So that means our revenue, I'm going to continue up here, our revenue should be equal to our revenue function, which we already had from part A, 120x minus 0.5x squared. That's our revenue. Sorry, this should be profit. Oops. Our profit should be equal to our revenue minus, now what about the cost? So I'm subtracting cost now, right? My cost is 1,000 plus 9x, right? Be very careful. This has to be in parentheses, because you must distribute the minus through to both terms. So this is your revenue minus this is your cost. Everyone clear on that? And isn't my profit going to have just one variable in it, just x? Right? There's only x's in here. So I'm going to write p of x equals 120x minus 0.5x squared minus 1,000 minus 9x. So I went ahead and distributed the negative through to both of those. Questions? Let's collect any like terms together. I see that 120x and I can take away 9x. So p of x is, let me put this, put it in descending order, negative 0.5x squared. And then I'll have plus, what is that, 111x minus 1,000. So all I did there was put the 120x, took away 9x. And that's my profit function. So now what? Find the derivative, right? Set it equal to 0, test points, all this thing again, right? So derivative of this is equal to negative x. That's what happens when the 2 comes down. And then plus 111. I don't know why I put squared, sorry. So derivative of this is 111, derivative of that is 0. Set that to 0. That means you're going to set negative x plus 111 equal to 0, and that's a pretty straightforward answer right there again. That's x is 111. Test points, all this? I'm not even going to do it, but it goes up and down, okay? It does go up and down. So what does that tell me? I have maximum profit when x is 111, right? So max profit if we sell 111 units. Now part D. The maximum profit is, now how do we get the maximum profit? We take the 111, right, and we plug it into the profit, where is it? Right here, this one. So plug 111 into this, and somebody will do that for me. I'll put here is P of 111, so just plugging 111 in here. Should the answer be bigger than 7,200 or less? What do you think? Bigger? Less. The reason it's less is because, see, revenue does not take into account that you have to pay people and, that. So your profit's going to be less, but it's the most money that you can possibly make, is what we've found. So what did it come out to be? 5,160 point something? 0.5? Okay, close enough. So I think, excuse me, I think that if I'm running this business, right, I'm more interested, well, you tell me, what are you more interested in? Are you more interested in maximum revenue or maximum profit? Profit. Probably profit, right? I mean, you still have to pay your bills, right? You have to pay the people, you have to run your business, that costs money. So you want to figure out how many of these things you need to manufacture and sell to maximize this number, not this one. Right? It's one of those interesting things about, these business models, is that we don't necessarily look at what will bring in the most money. We actually have to think about how much it costs us to make and sell these things. All right, how you feeling? Huh? So number 7 is the same thing as number 6. The only difference is, look at your P right there. See where it says 200 minus x over 50? That's just to confuse you a little bit, I guess. Let's just work through 7. Let's just get it set up. I may not do all the work, but let's just get it set up. So for number 7, can you tell me what my revenue function is? Again, I'm not going to work through a bunch of stuff here. What's my revenue function going to be? X times 200, in parentheses, 200 minus x over 50. Right? That would be my revenue function. And let's distribute through. This would be 200x minus x squared over 50. And it's that x squared over 50 that I think causes the most problem. But just look at it this way. That's the same expression. Instead of having a 50 below the x squared, just slide it out as a 1/50th. Right? It's kind of like if I write x over 2. That's the same as half of x. Right? That's all I'm doing. And then you can get on your calculator, and if you like, you can just figure out what 1 over 50 is. Right? And you'll get 0.02. So this is 200x minus 0.02x squared. That is your revenue function. So then you would take the derivative, you'd set it equal to 0, you'd do number line test points up, down, and you'd get your answer, right? We don't need to go through that, or we do? We're okay? All right, so that would take care of your revenue. Now to do profit, to find my profit function, I'm doing my revenue minus my cost. And my cost is given as, what's 60,000 plus 60x? So I'm going to, in parentheses, 60,000 plus 60x. Again, parentheses, the minus is going to go through, distribute. Let's clean this up. Profit is 200x minus 0.02x squared minus 60,000 minus 60x. You think you could just put things together there now? Right, just group things together. That's your profit. Questions? Just ask. You got tests in 2 days. I don't. Profit is always going to be revenue minus cost, right? This subtraction symbol applies to everything everything here. So if you have more than one term, you've got to have parentheses around it. All right? Right here, this right here is your cost. All right? So I'm subtracting the whole thing. You must have the parentheses. Yes?
I don't know why we're not here. Is the revenue, we did revenue right
Mhm.
away, right? When the equation is for profit, why are we doing that?
The question asks for two different things.
Oh, so you did the,
Right? The question, part A says, try and find the maximum revenue. All right? So I work with the revenue function, and only the revenue function. And then,
oh, because it's P times X. Okay, then I'm just kidding about it then.
yeah, revenue, this is, I don't like this about business, okay? The way that they present this. Revenue is X times P. This P is not that P. This is lowercase p, this is uppercase P. This is the price, this is the profit. So they're two different P's. Good? Okay. Any other questions? You sure? All right, so let's keep going. Let's go backwards here. Number 5. Find the absolute maximum and minimum value. So number 5 is actually different than what we've been doing. Because on all the problems I've done this up to this point, what we've done is we've taken the derivative at some point, we've set it equal to 0, and then we pick test points, right? Number 5, you do not do that way. And the reason why is because I give you an interval. Okay, so let's talk about how you do number 5. Number 5, find the absolute max and min of this function, f of x equals x to the 4th minus 18x squared. See if anyone remembers how to do this. You don't need second one for this one. Just the first.
Oh, no, that's number 3.
Yeah, you're thinking number 3.
Isn't, we're only looking at this part of the graph.
That's right, you're only looking at part of the graph. So go ahead.
Okay, I was gonna say, is this set the derivative equal to 0?
Okay, so let's take the derivative first. How about that? Let's get our derivative. What is that? 36x, right? Everyone agree? Now, you said set that to 0. I agree. We're going to do that. So far, nothing is different than what we've done before. Take it, set it equal to 0. So take 4x cubed minus 36x equals 0. All right, let's take our time through this here. How do you solve that equation? That's not a standard, nice little linear equation. You got to do a little work first. Greatest common factor, you take out a 4x first. You can take out a 4 and an x. If I do that, what am I left with? If I take a 4 and an x out of here, what's still here? X squared, and then minus. I took a factor of 4 out of here, so 9, and then I took the x out, so just 9 equals 0.
And don't you set both of those to 0?
You're supposed to set both of these equal to 0, yes. However, there's something that we can still do here. What is this? This is a special one, difference of squares. You have to recognize this is a difference of squares. So this turns into x plus 3 times x minus 3. So I'm going to do that. 4x, x plus 3, x minus 3 equals 0. So that right there, this comes from this piece right here, is something you have to recognize. Now you can set all of them equal to 0. So I can set this to 0. I can set x plus 3 to 0, and x minus 3 equal to 0. So 3 separate things equal to 0. We should get 3 different answers. What are they? X is 0, negative 3, and 3. Now remember, in the original problem, didn't I say to look between negative 1 and 1? Right? So this is where you have to go and make sure, do these lie in here? They don't, right? Only one of them does, right? So if this had been between -4 and +4, they would all work, right? We would use all of them. But you know what? Let's change that to a 4 just to make this a little more interesting. Let's change this to -1, 4. All right? Change it on your sheet there. Which of those do I throw out? Just the -3, right? I do not need to worry about that one. Okay, so here's where things change. You are not going to do a number line and test points. What are you going to do? You're going to plug in these answers into the original function. Not only these answers, but what else? The 2 endpoints. So you're going to go back to the original function f. You're going to plug 0 in. You're going to go to the original function f and plug 3 in. You're going to go to the original function f and plug in -1. You're going to go to the original function and plug in 4. And you don't have to do these in this order. Do them in any order you want. It does not matter as long as you get them all. These 2 and those 2. And you're going to compare them, right? And you're going to try and figure out which of these is the biggest and the smallest. Okay, I'll do this one because this one's easy. Plug in 0. Gone, gone. I just get 32. And then you have to plug these in. Are there any questions while I'm plugging these in? Okay, when you plug in 3, you should get -49. When you plug in -1, you should get 15. And when you plug in 4, you should get 0. So I'm not showing that work, but everyone understand you're replacing these x's in here, not in the derivative, in here. So the question asks, to find the absolute maximum. What is the absolute maximum value of this function on this interval? What is it? 32. Right here. This is the maximum. This is the absolute maximum. All right. And the absolute minimum is the -49. On this interval, the highest that graph will ever get is 32, and the lowest it will ever get is -49.
Okay, that's my question. So I remember doing that spot, that's why I have it. I put the local minimum at x equals 3, and the local maximum at x equals 0, which is, or the absolute, I'm sorry.
Mm-hmm.
And it came out to the same, I got those answers, but is that what you're asking for, is like the outcome?
The outcome, well, it says, yeah, because it says what is the maximum value and minimum value. So if you wrote down, you know, the absolute maximum at 0 is 32, that's fine. But when they say value, they just want this. I always like to know where it happened. So if I were you during the test, here's the way I would do it. I would just write it like this, okay? And then when you get your answers, just next to it write absolute max and min. And see here, you can see everything. The maximum value is 32. It happens when x is 0. Minimum value is -49. It happens when x is 3. Okay. Let's see here. Number 4. Number 4 is exactly like number 6 and exactly like number 7, but only parts A and B. So for number 6 and number 7, you have you're asked for a revenue function, trying to find the max and min of it. Oh, but it also asks about concave. Oh, I missed that one, sorry.
So that's just the second derivative.
That's second derivative. Yeah, let's work through 4. We still have about 15 minutes, right? Okay. So number 4, I do not anticipate your test being this long, okay? That's not necessarily a good thing though, because that means there are going to be fewer problems. That means they're going to be worth a lot, right? So you can't make mistakes.